Hello friends, welcome to PrepTab. In this video, we are going to revise the formulas for hydrolysis of salt, which is from Ionic Equilibrium chapter. Along with that, I'll also give you some practice questions to which you can apply those formulas and you can post your answers in the comment section below. Clear? So let's start. Before starting, let us discuss how salts are formed, right? See, whenever an acid reacts with a base, it will lead to the formation of salt. Clear? Now it depends whether you are using a strong acid or a weak acid. The acidic strength or basic strength of the salt will depend on it, right? So if we have a salt which is formed from strong acid and strong base, it will form neutral salt. The salt formed will be neutral, and since it is neutral, so the pH of that salt will be 7. And for salt of strong acid and strong base, there is no hydrolysis of their conjugate ions. Clear? Because they are from strong acid and strong base. Clear? So one thing that is to be kept in mind is that if the acid is strong or base is strong, their conjugates will not undergo hydrolysis. Clear? So hydrolysis will be for conjugates of weak acid or weak base. Now second, we have a salt of weak acid and strong base. Now when the salt will be formed, since base is strong, so the salt will also be basic in nature. Clear? So that means its pH will be more than 7. First thing. Second, only hydrolysis of weak acid conjugate will take place, not of strong base. Clear? So it's the conjugate of weak acid will be, say, A minus. So this is known as anionic hydrolysis because only A minus will be hydrolyzed. Clear? What is H? H is degree of hydrolysis. It is given as under root KH by C. KH is hydrolysis constant. KH is given as KW by Ka. We know what KW is. It is 10 to the power minus 14 at 25 degrees Celsius. Right? Ka is the ionization constant of this acid. Clear? So that means the weaker the acid, its Ka will be smaller, right? Ka value will be less. So that means KH value will be more. If Ka is less, KH will be more. That means more hydrolysis will take place for weaker acids. Clear? pH is given as half of pKw plus pKa plus log C. Everything is positive. Fine. So you can remember these formulas. Only these formulas are sufficient. You don't have to learn anything else from this topic. Clear? Now third case is if we have a salt which is formed from strong acid and weak base. That means its pH will be less than 7. Clear? So now in this case, the hydrolysis of only the conjugate of weak base will take place. Clear? So it will be the hydrolysis of conjugate acid of this weak base, right? So it is known as cationic hydrolysis. Clear? And the formulas are same as that of anionic hydrolysis. You can see H is root KH by C, KH is KW by KB, and pH, you can see it is half of pKw minus pKb minus log C. Now you can see the difference in these formulas. Here everything is positive, and in this case you just have to remember that you have to use minus pKb minus log C. Clear? Rest everything is same. The one thing I would like to bring to your notice here is that if you are taking more concentration of salt, right, if this C is large, that means you are making a concentrated solution, the value of H, the degree of hydrolysis will decrease. That means there will be lower hydrolysis. Clear? So as C increases, hydrolysis will decrease. That means you have to take dilute solutions for hydrolysis. Fine? Okay. Now let us come to our last case, that is weak acid and weak base. Now you cannot identify the pH of this salt unless and until you are given the pKa and pKb values. Clear? For this, hydrolysis will be of both conjugates of weak acid as well as that of weak base. Fine. So you cannot classify it as anionic or cationic hydrolysis because both are getting hydrolyzed. So if you compare all the 4 cases, maximum hydrolysis is taking place in the case of weak acid and weak base. Clear? Second thing that you have to notice, H. In all of the other cases, you can see H is dependent on concentration. But over here, H is root KH by 1 plus root KH. It is independent of concentration. Okay, and third thing you can see, KH value, that is KW by Ka into Kb. Now I can tell you a very simple trick to remember all the formulas. See, for when you have a weak acid, you will get K, right? So KH is equal to Kw by Ka. When you have a weak base, it will be KH equals to Kw by Kb. And when you have both weak acid and weak base, KH will be Kw upon Ka into Kb. Clear? So you can relate all of them. Now same way come to pH. See, it is half of pKw plus pKa minus pKb. There is no role of C. Now you can see for anionic hydrolysis we have pKw plus pK. For cationic we have pKw minus pKb. In this it is a combination of both. So you can say that pH will be equal to half of pKw plus pKa minus pKb. Clear? So remember it that way, because that way it will be easier to learn. Clear? And you don't have to learn anything or study anything from this topic. Only these formulas will be sufficient, but practice as many questions as possible. Now I'm giving you 2 questions. I'm sure you will be able to solve it by using these formulas, and then you can post your answers in the comment section below. So I hope you enjoyed the video. So please do like, share and subscribe. And if you have any query, you can mail me at preptabmail@gmail.com, or you can also post it in the comment section below. So thank you for watching.